When dealing with a split-wire duplex receptacle connected to a 120/240 volts multi-wire branch circuit, selecting the appropriate voltage rating for the receptacle is paramount for safety and compliance with electrical codes. The correct choice is a 250 volts rated receptacle. This is because in a multi-wire branch circuit, the potential difference between the two ungrounded conductors, often referred to as hot wires, is 240 volts. Although each individual receptacle outlet provides 120 volts when measured from either hot wire to the neutral conductor, the receptacle itself must be rated to withstand the full potential voltage present within the circuit. Selecting a receptacle with an inadequate voltage rating, such as 125 volts, can lead to several hazardous outcomes. Firstly, it creates a risk of dielectric breakdown, where the insulation within the receptacle fails due to the high voltage stress. This can result in arcing, overheating, and potentially electrical fires. Secondly, using an incorrectly rated receptacle violates electrical safety standards and the National Electrical Code, NEC, which mandates that all electrical components be rated for the maximum voltage to which they may be subjected. Thirdly, it can compromise the integrity of the entire electrical system, leading to premature failure of the receptacle and potential damage to connected appliances or equipment. To ensure safety and code compliance, it is crucial to understand the configuration of multi-wire branch circuits. In a typical 120/240 volts multi-wire branch circuit, two ungrounded conductors, each carrying 120 volts relative to the neutral conductor, are supplied from opposite phases of the electrical service. The neutral conductor serves as a common return path for both circuits. When a load is connected between one hot wire and the neutral, it operates at 120 volts. However, when a load is connected between the two hot wires, it operates at 240 volts. The receptacle must be able to safely handle the 240 volts potential between the two hot wires. The NEC provides guidelines and requirements for selecting and installing electrical components, including receptacles. Article 406.4 E covers the rating of receptacles and cord connectors. It specifies that receptacles shall be of such design and construction as to be suitable for the voltage and amperage applied. This means that the receptacle must be rated for the maximum voltage that could be present in the circuit. The NEC further emphasizes the importance of using listed and labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Using listed receptacles ensures that they have been evaluated for their ability to withstand the rated voltage and current. When installing a split-wire duplex receptacle, the two halves of the receptacle are supplied by different hot wires from the multi-wire branch circuit. This allows two separate 120-volt circuits to be served from a single receptacle outlet. However, because the receptacle is connected to both hot wires, it must be rated for the full 240 volts potential between them. The process of selecting the correct receptacle involves several steps. Firstly, identify the type of circuit. Determine if it is a standard 120 volt circuit or a 120/240 volts multi-wire branch circuit. Secondly, determine the voltage rating. For a 120/240 volts multi-wire branch circuit, a 250 volts rated receptacle is required. Thirdly, check for listing and labeling. Ensure that the receptacle is listed by a recognized testing laboratory and bears the appropriate markings. Fourthly, inspect the receptacle for damage. Before installation, carefully inspect the receptacle for any signs of cracks, breaks, or other damage. Do not install a damaged receptacle. Fifthly, follow the manufacturer's instructions. Install the receptacle according to the manufacturer's instructions and all applicable electrical codes. Ignoring these steps can have serious consequences. Using an incorrectly rated receptacle can lead to electrical shock, fire, and property damage. It can also void the warranty on the receptacle and any connected equipment. Moreover, it can result in fines and penalties from electrical inspectors. In addition to selecting the correct voltage rating, it is also important to consider the amperage rating of the receptacle. The amperage rating should be equal to or greater than the maximum current that the circuit is expected to carry. For example, a 15 amp circuit requires a 15 amps or 20 amps rated receptacle. A 20 amp circuit requires a 20 amps rated receptacle. Furthermore, it is essential to use the correct wiring methods and techniques when installing receptacles in multiwire branch circuits. The neutral conductor must be properly sized and connected to ensure that it can safely carry the neutral current. The hot wires must be connected to the correct terminals on the receptacle to prevent reverse polarity. The receptacle must be securely mounted in the outlet box to prevent it from coming loose. The use of a properly sized ground wire is also crucial for safety. The ground wire provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The ground wire must be connected to the grounding terminal on the receptacle and to the metal outlet box, if used. When working with electrical circuits, it is always recommended to follow safe work practices. Firstly, always turn off the power to the circuit at the circuit breaker or fuse box before working on any electrical components. Secondly, use a voltage tester to verify that the power is off. Thirdly, wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Fourthly, never work on electrical circuits while standing on a wet surface. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Regular inspection and maintenance of electrical systems are also important for preventing electrical hazards. Receptacles should be checked periodically for loose connections, cracks, and other damage. Worn or damaged receptacles should be replaced immediately. Circuit breakers and fuses should be tested to ensure that they are functioning properly. Electrical panels should be kept clean and free of obstructions. In conclusion, selecting the correct voltage rating for receptacles in multiwire branch circuits is crucial for safety and code compliance. A 250 volts rated receptacle is required for 120/240 volts multiwire branch circuits. Following safe work practices and performing regular maintenance can help to prevent electrical hazards and ensure the safe operation of electrical systems. Understanding the function of ground fault circuit interrupters, GFCIs, is also crucial. GFCIs are designed to protect people from electrical shock by monitoring the current flowing in a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing injury. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electric shock. When installing receptacles in these locations, it is important to use GFCI-protected receptacles or to install a GFCI circuit breaker to protect the entire circuit. Arc fault circuit interrupters of size are another important safety device. ASIs are designed to protect against electrical fires caused by arcing faults. Arcing faults can occur when damaged or deteriorated wiring creates a path for electricity to jump across a gap. This can generate heat and ignite nearby flammable materials. ASIs detect arcing faults and trip the circuit, preventing a fire. ASIs are required in many locations, such as bedrooms, living rooms, and dining rooms, where there is a high risk of fire. When installing receptacles in these locations, it is important to use ASI-protected receptacles or to install an ASI circuit breaker to protect the entire circuit. Surge protection is also an important consideration for protecting electrical equipment. Surges are sudden increases in voltage that can damage sensitive electronic devices. Surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protectors are designed to absorb surge energy and prevent it from reaching connected equipment. Surge protectors are available in various forms, such as whole house surge protectors, which protect the entire electrical system, and plug-in surge protectors, which protect individual devices. When installing receptacles, it is important to consider the need for surge protection and to install appropriate surge protection devices. Furthermore, understanding the importance of proper grounding and bonding is crucial. Grounding refers to connecting the electrical system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Bonding refers to connecting all metal parts of the electrical system together. This creates a low impedance path for fault current, which helps to ensure that the circuit breaker or fuse will trip quickly in the event of a fault. Proper grounding and bonding are essential for electrical safety. The National Electrical Code (NEC) provides detailed requirements for grounding and bonding. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. In addition to the NEC, there may be local electrical codes that must be followed. Local electrical codes may be more stringent than the NEC. It is important to check with the local electrical inspector to determine what codes apply in a specific area. Also, selecting the correct type of receptacle for the application is essential. There are various types of receptacles available, each designed for a specific purpose. For example, there are standard duplex receptacles, which have 2 outlets. There are also single receptacles, which have 1 outlet. There are tamper-resistant receptacles, which have shutters that prevent children from inserting objects into the outlets. There are weather-resistant receptacles, which are designed for use in outdoor locations. There are also locking receptacles, which are designed to prevent accidental disconnection of plugs. When selecting a receptacle, it is important to choose the type that is appropriate for the application. Proper labeling of electrical panels and circuits is crucial for safety and troubleshooting. Each circuit breaker or fuse should be clearly labeled to indicate what it controls. This makes it easier to identify and turn off the correct circuit when working on electrical components. It also helps to prevent accidental overloads, which can cause circuit breakers to trip or fuses to blow. Electrical panels should also be labeled with the voltage and amperage of the service. In addition, using the appropriate tools and equipment for electrical work is essential for safety. This includes insulated screwdrivers, pliers, and wire strippers. It also includes a voltage tester for verifying that circuits are de-energized before working on them. Using the wrong tools or equipment can lead to electrical shock or injury. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. Hiring a qualified electrician can help to prevent electrical hazards and ensure that the electrical system is installed and maintained properly. Finally, keep electrical components clean and dry. Dust, dirt, and moisture can damage electrical components and create a fire hazard. Electrical components should be cleaned periodically with a vacuum cleaner or a damp cloth. Avoid using excessive water or cleaning solutions. Damaged or deteriorated wiring should be replaced immediately. Frayed, cracked, or otherwise damaged wiring can create a fire hazard or an electrical shock hazard. Wiring should be inspected periodically for signs of damage. If any damage is found, the wiring should be replaced immediately by a qualified electrician. Regular maintenance of electrical systems is also very important. Electrical systems should be inspected periodically for loose connections, damaged components, and other potential problems. Any problems that are found should be corrected promptly to prevent them from becoming more serious. Regular maintenance can help to extend the life of the electrical system and prevent electrical hazards.